Hey there, everyone, Alejandro. Welcome back for day 269 of me doing Daily LeetCode challenge. That's to reach 1 year's worth of green contributions here on GitHub. So today is for April 11th, 2025. And without further ado, let's get straight into it. Okay, today we get LeetCode Easy. And ooh, okay, congratulations, 100 days badge 2025. Well, I thought I got this before. Oh no, maybe I got the 50 days badge. Okay, that's pretty cool. Yeah, I'll save this just in case. 100 plus days in 2025. In 2025. It's already been that many days? Oh, I guess 31 for January, 28th. So yeah, quick terminal maths here. It's been janvier, février, mars. 31 for January, 28 for February. Might have been 27, 28 or 29 on a leap year. It was not a leap year. Janvier, février, mars. Okay, 31 for March. Then we're on 10th day of April. Yeah, okay, 100 days. Okay, nice. So it's for the year 2025. Okay, that's pretty cool. Okay, so nevertheless, today we get LeetCode Easy from 2843 count symmetric integers. You're given two positive integers, low and high. An integer x consisting of 2 times n digits is symmetric if the sum of the first n digits, let me increment the brightness here. The sum of the last, okay. Are never symmetric. I see. Is low to high? Yeah, so low to high is up to 10 to the 4. Yeah, I'm not liking these counting problems. So it's either like combinatorics or DP. Yesterday's was pretty brutal. Yeah, this is going to be very easy because you can go to this in linear time. I wonder if like 2844 is like a medium of this where it's like you can't go in linear time. I mean, for now, let's just do what's easy. We'll do a def. Is symmetric, right? Here we'll say is symmetric equals lambda num, length of num modulo 2. And of num over 2. Yeah, def is symmetric. Num. I will just make this a self. Length is equal to length of num. Sternum is equal to string of num. Length modulo 2 is equal to 1. Return false. Of int digits. Sternum of I. Length Yep. Return sum of num in range, low, high, inclusive. string num. Okay, that's accepted. Let's submit. And there we go. Bada bing, bada boom. Completion streak 269 days. Consistency is key. See ya tomorrow. Okay. And yeah, this is exactly what I figured. There's going to be much faster ways to do this than the 10 to the 4 time. That is a lot of it, just like yesterday. Although yesterday's problem kind of traumatized me, I'm not even gonna lie. Maybe I should learn how to do digit DP, right? If I can't do combinatorics and there's a DP way of going about things, maybe I should learn how to do things in terms of DP, right? Okay. Well, okay. I guess I want, you know what? Okay, I'll do the solution explanation. Then we'll look at hints, editorials, and stuff like that. Okay, so nevertheless, as always, now my videos, I do a quick recap of that will solve the problem. So here we essentially want to return the count of numbers in the interval low to high such that that number is symmetric. And a number is symmetric if and only if it has an even amount of digits, and the sum of the first half of the digits is equal to the sum of the last half of the digits, right? So here I created a function called asymmetric. Basically, it'll take a num, convert it into a string. Here I'll say, okay, length is equal to length of string num. If it's odd in length, return false. Otherwise, here's like, okay, take the sum of the first half of the digits, the sum of the second half of the digits, and return whether or not they're equal, right? So if they're equal, return true, otherwise return false, right? And here I'm just going to return the sum of, for each number in the range low to high plus 1, I'll add 1 if it is symmetric, otherwise 0 if it's not symmetric, right? In Python, true converts to 1, false converts to 0. So if I do the sum of stuff that is symmetric with num for each number in the range low to high, all inclusive, then essentially I'll have the number of numbers in the range low to high that are indeed symmetric, and that is pretty much it in terms of how I was able to solve this problem. If anything, we could probably do this in one line. All right, so here I could just do you will say length of string num modulo 2 equals 0. Right, here I can probably do something like this. Let's just do return length of string num modulo 2 equals 0. Right, something like this is fine. Length of sternum, string of num. Okay, so that's accepted. Okay. So here, we'll just slap this into here. And now, we just put this in one line. And this is a working solution, right? There we go. One line of code, Python solution. Yo, Osmani.
What's up?
Come here. Do you like my solution to this problem? See if you can read it.
Oh god.
It's one line of code. It's just one line of code. Easy to understand. This is how I'm to write code at my company.
Oh my god, this is accepted.
Yeah, this is works.
It beats 5%.
Yeah, this is another combinatorics problem. Okay, the only thing is it's an easy, just because low and high are up to 10 to the 4. Basically, yesterday it was like another similar kind of problem. But it was like 10 to the 15 possible numbers. So here I can linearly go through low to high, right? So check the number of valid numbers from low to high plus 1. Yesterday was 10 to the 15, so you cannot iterate over all the numbers. For another problem, right? I know there's two ways of doing this, either combinatorics or digit DP. If I can't understand how to do combinatorics well, I need to understand how to do DP. So for now, I've essentially done the explanation of how I was able to solve the problem. So for now, I'm essentially going to dive into the topic where I'm going to look at the hints, look at the editorial, and see if there's a better way of solving about things after that I now solve this problem, just because I'm really terrible with combinatorics. But if there's a DP way of solving these types of problems, i.e. whatever digit DP is, I really want to learn that technique, because anything that can help me avoid combinatorics is a yay in my book. So, okay, let's look at the hints here. Okay, the hints is to literally iterate over low to high to a string and okay, well that's literally what I did. You don't even have to convert into a string. You can just do everything by base 10 and divide and so on, but okay, they're even lazier than that, just like I was, so that's cool. Okay, I'm gonna look at the editorial. Is there a digit DP way of doing things? Okay, not really. They just did basically that, but they just don't use strings. They use modulo 10s and stuff. Okay. Does anyone have a discussion for digit DP? Examples, don't worry, it's tricky. Yeah, O of n solution. What's the, no. This is my O of n solution. Is there nothing better? Optimization? Okay, maybe there's no digit DP. I'm just gonna go back to yesterday's LeetCode hard and learn that digit DP trick on my own and so on. Doesn't seem like there is that trick for this problem, but nevertheless, we solved this problem. I guess I don't know if it's necessarily optimal. I don't know if this accepted is because people are using like modulo and divide by 10 instead of converting it to a string. Probably definitely faster than the string stuff, but like I see some here at 0ms. I'm guessing there's maybe a digit DP or whatchamacallit, combinatorics way of doing this. So I'm going to invest in learning how to do digit DP. Sounds like a useful technique, especially if we're going to get a bunch of counting problems now from LeetCode, which is probably going to be my absolute biggest nightmare scenario that could possibly happen. But yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then.
Oh, I don't know.
Yeah, you do.
See you next time.
No, it's your favorite word.
Bye-bye.
No, close.
Something, my friends.
Italiano.
Arrivederci.
No. Español.
Español.
Cuando digas adiós.
Uh,
Ciao, ciao, my friend.
oh,
Bye bye.